One of the lessons in Unit 3 is vertical circular motion. The main formula for this is force net equals mass times velocity squared over the radius. Force net means the total forces on an object. Let's say you have a ball and you're swinging it vertically on a string. The two forces acting upon it are force gravity and force tension. Now if you try and stop it at the top, most likely what will happen is it will fall out of its path of motion. Because both forces are pointing towards the center and they're pointing in the same direction, you add them in your equation. Force tension plus force gravity. Now let's say that you want to stop the ball at the bottom. Force gravity is still pushing down, but force tension is pointing up towards the center. What will most likely happen is the rope could break. Because force tension is pointing towards the center, that is what's positive. So you subtract force gravity from force tension in your equation. Now there are three types of cases for vertical circular motion. The first case is on the top of the loop of a roller coaster. The two forces are force gravity and force normal. They're both pushing down on the tracks or on the car. It doesn't fall out of place because it wants to move up, and the track helps it stay in place. So since both forces are pushing down, you add them in your equation to equal your force net. So it'll be force normal plus force gravity. The faster you go around the circle, the faster and sharper, the safer you are, and it's a lesser chance of going upside down, so you want to go faster going around the loop. The second case is when you're at the bottom of the loop. Force gravity is pushing down and force normal is pushing towards the center. The only dangers about this is you could pull too many G's as you're going around, since you're going so fast around the loop that if you go too quick, you could black out because of the loss of blood in the head. Most roller coasters stay around 3 G's. Now since force normal is pointing towards the center, you're subtracting force gravity from it. So it'll be force normal minus force gravity in your equation. One thing that doesn't affect the amount of G's is the mass of the object in the car or the car itself on the roller coaster. Third type of case is going over a hill. You have force gravity pushing down and force normal pushing up. The only danger to this is if you go too quickly over the hill, you could go airborne and fly out. Now in this case, since force gravity is pushing down towards the center and force normal is pointing up, you're subtracting force normal from force gravity in your equation.